All right, here's page 3 of the Algebra 2 Chapter 6 review, and this is the calculator part. So and also read it says polynomial equations can be solved with a calculator. Polynomial equations would be like x squared plus 3x equals 5x plus 9. There's no fractions in it as the exponents, or it's not like it's not like this. You would change that to a polynomial equation, first of all, by multiplying 3x plus 2 on both sides, so it looks more like this. We've talked about that in class by this point, so you'll understand what that means. So first question is an exponential equation, and you can get the same base here. They both have a common base of 3. So the first thing we're going to do is get that common base. 9 is 3 to the second. 27 is 3 to the third. So now I have to bring this 3 to the second up. Oops, I forgot my 4x. My mistake. Hopefully you caught that as I was doing it. So I have to bring this 3 to the second up. It becomes 3 to the negative second. And that's still to the 4x. For this exponent, I'm going to multiply the exponents. Remember to distribute 3x minus 9. So make sure you distribute. So now we're going to multiply these exponents. I could have done that. You could do that all in one step. And then since we have the same base, you can set the exponents equal to each other. So I'm going to subtract the 3x on this side. So I have negative 8 minus 3 is negative 11. So I have negative 9 over negative 11. And a negative divided by a negative is a positive. And now I'm going to make sure I check that in the calculator. I'm going to do that later. If you have a calculator, you should check all of these. So I will actually probably post another video just to remind you how to do that. So number 12 is another exponential equation, but this one looks like you won't be able to get the same base. So we're going to solve this just by undoing everything. So the first thing you're going to undo is get rid of that minus 12. Just how you normally would solve an equation. So add 12 to both sides. (38 plus 12 is 50). So now we have this exponential equation, and we're going to have to take log base 6 eventually, but don't do that too soon. You have to get rid of this 5 because it's 5 times that exponent. So divide by 5 next. 50 divided by 5 is 10. Now you can get rid of that 6. It's an exponent, so don't divide it. Log base 6 both sides. That's the only way to cancel out that base of 6 if it's an exponent. So log base 6 and 6 will cancel each other out. Log base 6 of 10, you're going to have to do on your calculator. You can leave it as log base 6 of 10 if you want. Or since this is a calculator part, you can actually type that in the calculator. And I got 1.29. I'm going to round it to 2 decimal places. Add or subtract 4. Just continue on your calculator with that. I get negative 2.71. Make sure you check that. Again, I'm going to check that later. And those are those two equations. So 13 and 14. All right, so these are log equations, and the difference between these and the one we did on the page before this is these have uh, logs that you're going to have to condense. You always condense first. So always condense any log first. So let's see what I'm going to do with this one. Two logs here. It's a plus. So it's going to be the log of x times x plus 10. Now these logs have base 10 because you don't see anything, but it doesn't really matter because this is an equation where you have a log, well, one single log after we condensed equals another single log. So you can just set this and this equal to each other. That's a property. So you can say x times x, x times x plus 10 equals 24. Now this is something you can do on your calculator. I'm not going to use the calculator though. Again, I'll show you that in a separate video. I'm going to do it with algebra. So multiply the x through and subtract the 24. So we have to factor this. Factors of negative 24 that add up to 10 are negative 12 and or positive 12 and negative 2. So we know x equals negative 12, x equals 2. With log equations, you have to check for extraneous solutions. Plug them in, and if you can't take the log of 0 or a negative number. So if one of these will make you take the log of a negative number, it's extraneous. So look at x equals negative 12. If you plug it into this x, it's log of a negative. So x equals negative 12 is extraneous because you can't take the log of a negative number. So the only solution is x equals 2. That brings us to number 14. And the reason why number 14 is different from number 13 is you're still going to have to condense these logs, but for 13 you have logs on both sides, 14 you don't. So 14 you're going to eventually have to change this to an exponential equation. So first condense, as always. So you can change this to log base 6 of 3x plus 1 times 3 equals 2. At this point, you should change it to an exponential equation, just like we've done before on this review. 6 to the second equals this, 3x plus 1 times 3. So 6 to the second equals 3 times 3x plus 1. Now again, you can use a calculator on this because it is a polynomial equation to get your answers. But make sure you still check for extraneous ones after you use your calculator. Again, I'm not going to. That's 36. Multiply the 3 through, 9x plus 3. So we're going to subtract 3. So we're going to have 9x equals 36 minus 3. And divide by the 33, or divide by the 9. And we have a solution of x equals 33 over 9. And that's the answer. And again, check that on the calculator. So that was the bulk of this review, those equations, and it is really the most important part of the chapter. The next two problems are just simply calculator questions. So they're pretty easy. You just have to know how to do on a calculator. So I'm going to open up this calculator. I mean, if you can do these, you can just stop the video here, obviously. But if you can't, make sure they're so easy because you have a calculator. Make sure you get it. Log base 12 of 171. You can use that change of base formula if you remember what it is, but you don't have to. That's going to come later on the review. The log base is found on math, and then just look for it. It's way down there. Or the shortcut to log base is math alpha math. So 12, 171, 2.069, 2.07 if we're rounding to the, it says round to 2 decimal places, so 2.07. And finally 16, that's just plugging it right into the calculator. You just have to find the E. You should know where that is by now, but if you don't, it's right above the natural log. So second ln, negative 3 over 4, and enter 2.834, so 2.83. That was page 3 of the review. Page 4 is going to come next.